Okay, so we are going to talk about how to balance in basic solution. So when we're balancing a redox equation or a redox reaction in basic solution, it is essentially the same process as balancing it in an acidic solution. But since we do not have hydrogen ions available in the solution, at the end we're going to go back in and we're going to add hydroxide ions to neutralize those hydrogen ions, turn them into water, and pull from hydroxide ions that are available to us. So, as always, we're going to start by assigning oxidation states. So we have a -2 for the oxygen. We have a total of -8. -8 plus something gives me -1. So this something must be a +7. We know that the bromine, being a monatomic ion, has an oxidation state of -1. We know that oxygen has an oxidation state of -2. There are 2 of them. That must mean that this manganese is now a +4 since this is a neutral compound. We know that oxygen is -2. There are 3 of them, so that means a total of -6, but this is the bromate ion, so we have a +5 here on the bromide ion, or the bromine. Okay, so our manganese is going from a +7 to a +4. That means that it has gained 3 electrons. Our bromine is going from a -1 to a +5. That means that it has gone to it has gained 6 electrons. Now we're going to separate out our half reactions. So we have the permanganate ion forming the manganese 4 oxide, or manganese dioxide in the old naming convention. We have the bromide ion forming the bromate ion. And now we're going to first look at our elements that are undergoing redox. That would be the manganese and the bromine. Those are already balanced for number. We need to now balance the oxygen by adding water. So we're going to add 2 water molecules to the right side, which is then going to require me to add 4 hydrogen ions to the left side. Here we're going to need to add 3 water molecules to the left side, which is going to require me to add 6 hydrogen ions to the right side. And now we're going to look at charge, because the hydrogen, oxygen, and all the other atoms are now balanced. I have a total charge on this side of +3, a total charge on this side of 0, so I'm going to add 3 electrons to balance that charge. Now I have a total charge on this side of 0 and a total charge on this side of 0. And we're going to stop and check, and we see that we looked at oxidation states. We noticed that manganese gained 3 electrons. That's what we have written in our equation, so that matches up. So we're ready to move on. Here we have a total charge on this side of -1 and a total charge on this side of +5. So I'm going to add 6 electrons on this side to bring the charge on the right down to -1. And again, we stop and check. Our oxidation states told us that we expected to gain 6 electrons. We gained 6 electrons. We lost 6 electrons. Sorry. We didn't gain 6 electrons here. We lost 6 electrons. See, even I do that. Okay. So we've lost 6 electrons. And now, because we have 3 electrons gained and 6 electrons lost, we're going to multiply this equation by 2, so that the number of electrons gained equals the number of electrons lost. That's going to give us 2 permanganate ions, plus 8 hydrogen ions, plus 6 electrons, which yields 2 manganese 4 oxide and 4 water. Okay, now we can combine these. We have two, this up a little bit, permanganate ions plus the bromide ion plus 3 water molecules plus 8 hydrogen ions plus 6 electrons yields 2 manganese 4 oxide plus the bromate ion plus 4 waters plus 6 hydrogen ions plus 6 electrons. And now we can cancel out things that show up on both sides. So we can cancel out the 6 electrons. We have 8 hydrogen ions on this side and 6 hydrogen ions on this side. So we can cancel out 6. That leaves me with still 2 hydrogen ions. We just subtracted 6 hydrogen ions from both sides. We have 3 water molecules here and 4 water molecules here. We can cancel out the 3, subtract 3 from both sides. This becomes 1 water molecule. And now we can simplify our equation. We have 2 permanganate ions and a bromide ion and 2 hydrogen ions, forming 2 manganese 4 oxide ions, a bromate ion, and a water molecule. But this equation is happening in basic solution. I don't have hydrogen ions. So we have to go back and add 2 hydroxide ions to both sides. When we do that, this is going to give me 2 water molecules on this side. Since I have 2 water molecules on this side and 1 water molecule on this side, I'm going to cancel out that water and leave 1 water on this side. We have now 2 permanganate ions plus the bromide ion plus a water molecule forms 2 manganese 4 oxide, a bromate ion, and 2 hydroxide ions. Now we have finally balanced our equation in basic solution. Alright, one more example, one more practice problem. We'll go back to acidic solution to practice this one. This is the dichromate ion plus the iron 2 ion forming the chromium 3 ion and the iron 3 ion. And so we're going to start, as always, by assigning oxidation states. We have a -2 on the oxygen for a total of -14. -14 plus something gives me -2. This must be +12. There are 2 of them, so this is +6. Each of these is a monatomic ion. That makes it easy. This is a +2 because that's its charge. This is a +3 because that's its charge. And this is also a +3. So we're going to check and see. The chromium gained 3 electrons. I'll try to be careful and not make a mistake this time. The iron, on the other hand, went from a +2 to a +3, so it lost 1 electron. And now we're going to separate out our half reactions. We have the dichromate ion forming the chromium 3 ion. We have the iron 2 ion forming the iron 3 ion. So first thing we've got to do is recognize that we have 2 chromiums here, so we're going to put a 2 over here to compensate. Now we have 7 oxygens on the left, so we're going to add 7 water to the right. Having added 7 waters to the right, we're going to add 14 hydrogen ions to the left. The iron is balanced. There's no oxygen, there's no hydrogen. So now we're ready to balance for charge. The total on this side is +12. -2 plus +14 is +12. The total on this side is +6 because we have 2 of the +3. So we're going to need to add 6 electrons here. And we're going to stop and check. We can see that here we said that it's going to gain 3 electrons, but there were 2 chromiums, so each of them is going to gain 3 electrons for a total gain of 6 electrons. And we have the iron, which is losing 1 electron. So we're going to add 1 electron to this side. So we have a total of positive 2 here and a total of positive 2 here. In order to be able to combine these two reactions, I need to multiply this one by 6 so that I have 6 iron 2 ions forming 6 iron 3 ions and 6 electrons. Now, I can see that when I combine these 6 electrons that are on the left and on the right are going to cancel out. So I'm going to go ahead and do that before I combine. So I have the dichromate ion, Cr2O7 2 minus. I have 6 iron 2 ions. I have 14 hydrogen ions forming 2 chromium 3 ions, 7 water molecules, and 6 iron 3 ions. Which brings up an important point. Order does not matter. You can write these in any order. So if it's easier for you to write these two and then this, that's totally fine. That's what I did down here on the right side. It's not what I did on the left side. The order is not important. Okay, this is our balanced equation. If you have any questions, as always, just let me know.